Hey TechKnowStuds! When it comes to our networks, or really any service that we're delivering to an end user, we want certain service levels. So what in this video we're going to talk about is those service levels, what they are, and then we're going to focus on high availability and what high availability means and how do we implement it. In this video, we're going to start out by talking about what a service level agreement is. What are those key elements that would go into a service level agreement? Then we're going to get into what high availability is and how we create redundancy on our network. We'll talk about our network that we've been building and what that looks like. And then we'll finish this off by talking about first Hop Redundancy Protocol, or FHRP, and see what it looks like on our network. When we are delivering a service to someone, whether it be some sort of end user or customer, there are certain key elements that need to exist. What I mean by that is, if I'm paying for a service, I want to make sure that service is available for me. If I am paying for an internet service, I want to make sure that it's up. If I'm paying for some sort of online software, but I can't get to it, that is no use to me. So we need to have that service available. Another thing that we would like to have is some sort of performance with that. If we can get to that software or we can get across that network, but it's really slow and it's a really miserable experience, then obviously I'm going to get really frustrated as a customer and I'm not going to want that service anymore. Another thing that we will want is some sort of level of security. And depending on what it is, we're going to want more or less security. For instance, if I'm accessing a bank and that's a service that I'm accessing, I want to make sure that that connection is secure. I want to make sure that they're safeguarding my money. I want to make sure that they're safeguarding my personal information. So there's a certain amount of security that I'm going to want out of my service. And then finally, one that an end customer doesn't necessarily want, but we want as somebody who needs to manage these services, is it needs to be manageable. And when we scale up, we want our networks to be able to grow and our services to be able to grow without a lot of headaches. So we'll talk about manageability as well, although in this video, we're going to focus on availability. There is also something called service level agreements, or SLAs. SLAs are between somebody who's delivering a service and somebody who's receiving that service. You can find the SLAs in possibly a contract or a terms of service. What it is it's agreement on what level of service somebody's going to get. A lot of times they specify something like the availability, how much uptime is going to be available. So for instance, if I have an internet service provider, how often are they down? Well, they will most likely have some sort of service level agreement around availability. And if they don't meet this availability standard, then you could be due some money back. They could give you a credit on your next bill because they have not met their service level agreement. Same thing with performance. If I have subscribed to a 200 meg connection or a gigabit connection, then I'm guaranteed a certain amount of performance for that availability, for that uptime. And if I'm not getting that, there could be that I get actually a credit back on my bill. If it's some services have security as well. So SLAs is between somebody who's delivering a service and somebody who's receiving that service, and it's an agreement or an understanding of what level of service is going to be delivered. One of those SLA examples is uptime. This is a really common measurement of how much is this service available to somebody. And more importantly, it actually measures what is the downtime of a server. So what I mean by this is that if I have an internet service provider, they may guarantee me some amount of uptime, and they'll guarantee that uptime for the month, or they'll guarantee it for the quarter, or they'll guarantee it for the year. So if I bypass that during the month, the quarter, or the year, then maybe I'll get some sort of money back for that month or quarter or for that year. And so an example of this is somebody may say that I have an uptime guarantee of 99% for the year. And so if they have a guarantee of 99% uptime for the year, that equates to they can actually be down for 3.65 days out of that year. So that's actually quite a bit. If I have 3 nines, and this is a really common measurement, like a lot of AWS services have a 99.9% guarantee there. And what they're saying is during the year, they could be down for a little over 8 hours before they ever will credit your bill back for this uptime. So 3 nines is very common. And 99.99% means that they can be down for almost an hour out of that year. So now that's going to be quite a bit more difficult to get to that level. That's going to be really hard to have 4 nines there. And notice what I say is 2 nines, 3 nines, 4 nines, 5 nines. So we commonly express this not as 99.99% uptime. We express it as 4 nines. And 5 9 for a lot of services is considered the premium. If you can guarantee 5 nines, then that's pretty powerful. If you maintain 5 nines, that's a very powerful statement right there. And what that means that you've only been down for just a little over 5 minutes out of the year. So that can be pretty amazing if your service is running at this level right here. Now the thing is that there's going to be problems on your network. Somebody could be hacking you, or equipment could go down, or a service could go down. There are things that are going to happen on your network that will go wrong. It's just a question of time, not is it going to go wrong. And so to compensate for this, if we want to maintain high availability, we have to create redundancies within our network. And it comes on multiple levels. Here's an example of a network right here that we maybe want to have some sort of redundancy involved. Well, first of all, we have to have redundancy within the infrastructure. What that means is that this network right here has power that is going to it. And we need to make sure that if that power fails, there's a backup solution for that. And many data centers have 2 or 3 different power sources from different types of power to back up their whole network. And the internet service provider, so there's some sort of connectivity that needs to have redundancy with it as well. Also, if we have power, your connections, there's also things like the HVAC or cooling that has to have redundancy within that network as well. Sometimes we have redundancy from an infrastructure standpoint where we have just a whole nother building that's maybe in another location, or what I set up is no whole nother region. So some of the services that I offer for the company that I work for, a lot of those are within the Oregon data center, but I also have redundancy over in a Virginia data center as well. So clear across the country, there's these redundancy with it. So that is the infrastructure redundancy. Within your network, you also want equipment redundancy. So here I've got multiple routers or multiple layer 3 switches, multiple access switches, multiple lines between all of these switches. I want redundancy even within this equipment. Not only is the equipment redundant, but within the equipment, then I have redundant power supplies, redundant controllers, redundant links on those switches and that equipment. So there's a lot of redundancy that's built in on every single level. The other thing too is not only can all of this equipment possibly fail, but if you have a server that is running a certain service, that can fail as well. That's why things like SQL and a lot of these different databases and a lot of different services have multiple servers running that same service, that if one were to fail, that could fail over to another service. So that's a whole nother level where you have redundancy as well. So within our network, we have created some redundancy. For instance, we created our switches have multiple links to each of the switches. Even this configuration here, right here, has redundancy involved as well. If we wanted to create redundancy with these routers, maybe we have another line that's connecting router 1 and router 3. Perhaps we have a whole nother internet service provider that's providing us services to the internet. Perhaps on this network right here, we have two routers that are running that are performing side by side. And so if one were to fail, then it would switch over to the other one. So there's a lot of, even on our switches, the switches that I'm using have redundant power supplies on them. So that we have been incorporating redundancy within our network already. Now, with this network right here, what I can do is I could actually plug this switch directly into this router right here. And this one's already running OSPF on it, and this one is running OSPF on it. And so we would create redundancy automatically. It would create and know the best route to get to these networks automatically, because that's what our routing protocol does. However, what we don't have redundancy in here is this core switch. This core switch is integral to providing services at this level down here. So with that, if this core switch goes down, we are not going to have the same level of connectivity on these different devices. So what we can do is we can create redundancy between two different switches. But of course, how do we implement this? Because this is holding the IP address as the default gateway for these other devices. So how do we, when this switch goes down, have this other switch take over and take on that same IP address? So for instance, this laptop right here, its default gateway is 10.1.10.1, which is on a SVI interface of our layer 3 switch. So if this switch were to go down, how does this switch over here take on this 10.1.10.1 IP address to become the default gateway for this laptop? Well, that's where first hop redundancy protocol comes in. It's the first hop. It's the first connection, layer 3 connection point of all of this. So this is FHRP, and this is how we would create redundancy for our default gateways. So there you have it. We start out by talking about SLAs, which is some sort of agreement between a service provider and a service receiver. And then we got into high availability and some redundancy and how that has to happen at multiple different levels. We talked about our network and how we've incorporated some redundancy with it. But one thing that is lacking is a redundancy from a default gateway perspective. And that's where first hop redundancy protocol comes in, is it can be a solution for providing that redundancy.